Hello, welcome to the Self-Learning Podcast by Dr. Sushma Singh. Let us start discussion on Unit 21, Survey Design. And our topic is Sampling Design. After survey design has been selected, a sampling plan must be chosen. Many details about sampling have been discussed earlier in the unit of Block 4 and Block 5. And therefore, I am including only those that are new. The first question is why sampling? Because the researchers may not include the whole of the population in survey research for reasons of cost and manpower. A part of the population is selected for understanding the characteristics of a population. Sampling, therefore, is a process of systematically selecting cases for inclusion in a research project. A researcher gets a set of cases or a sample that is more manageable and cost effective to work with than the pool of all cases. For example, it would be much less costly and time consuming to measure variables in 200 than 20,000 people. The researcher is not just interested in a small subset of cases. Instead, he would like to generalize about the entire pool. If well-done sampling lets the researcher measure variables on the smaller set of cases, but generalize result accurately to all cases. But instance, if sampling is well conducted, a researcher can measure variables with, say, 2000 cases and generalize to 200 million. Survey researchers argue strongly that there would only be 2 to 4% variation if all the 200 million cases were used for the study. The next question is how it is possible to generalize from a handful of cases. It is not based on any magic, but on logical statistical reasoning that has been tested repeatedly with empirical evidence. Moreover, a researcher cannot use just any sample for the purposes of generalization. There are well laid down sampling procedures that require rigorous exercises in order to increase the level of precision in a study. Now let us move to the point basic terms in sampling. The first is sampling element. A sampling element is the unit of analysis or case in a population. It can be a person, a group, an organization, a written document, or symbolic message, or even a social action like a divorce, a fight, etc. that is being measured. The second one is population. It is the large pool of elements from which a sample is drawn. Sometimes the term universe is used interchangeably with population. To define the universe or population, a researcher specifies the unit being simplest, the geographical location and the temporal boundaries of population. The term target population refers to a specific pool of cases the researcher wants to study. The third one is sampling ratio. The ratio of the size of sample to the size of the target population is the sampling ratio. For example, a college has 2000 students and a researcher draws a sample of 200 from it. Thus, the sampling ratio is 200 upon 2000 is equal to 0.1 or 10%. The fourth is sampling frame. A population is an abstract concept. Except for specific small populations, one can never truly freeze a population to measure it. For example, in a city at any given moment, some people are dying. Some are traveling outside the city. Some have gone on temporary migration to other cities, and some are taking birth. The researcher must decide exactly who to count. Should he count a city resident who happens to be on a holiday or outside the city when the time is fixed for study? Therefore, the notion of population is abstract and it exists in mind, but is impossible to pinpoint concurrently. Since it is an abstract concept except for small populations, a researcher needs to estimate the population. Thus, it requires an operational definition. A researcher operationalizes a population by developing a specific list that closely approximates all the elements in the population. This list is a sampling frame. The researcher may choose from many types of sampling frames: telephone directories, driving licenses, ration cards, membership of a club, students, registration in a university, etc. A good sampling frame is crucial to good sampling. A mismatch between the sampling frame and the conceptually defined population can be a major source of error. For instance, if you select the telephone directory as a sampling frame, it constitutes only 5 to 10% of the population in a city, say Delhi. The directory does not list those who do not have a telephone connection. It also does not update quickly the frequent shifts of residencies and changes in telephone numbers in a city. The fifth is parameter and statistic. Any characteristics of a population is a population parameter. For instance, students from the science stream of children in the age group 6 to 11 years, etc. It is the true characteristics of the population. Parameters are determined when all elements in a population are measured. The parameter is never known with absolute accuracy for large populations, so researchers must estimate it as based on samples. Researchers use information from the sample called a statistic to estimate population parameters. Now let us discuss sampling error. If many samples are taken from the same population, it is unlikely that they will all have characteristics identical either with each other or with the population. In brief, there will be what is called sampling error. Sampling error is not necessarily the result of mistakes made in the sampling procedure. Rather, variations occur due to the chance selection of different individuals. Now discuss is types of sampling designs. Sampling designs are of two types. The first is called probability sampling design and the second is non-probability sampling design. In Unit 15 of the Block 5, our focus was on how to carry out calculations, while here we are discussing each type of sampling design in terms of its essential character and procedure. All the same, you are likely to find some repetition of the subject matter which has been retained to reinforce the learning of the same, that we will discuss in our next session. Now let us wind up the session and take rest. Thank you very much for engaging yourself with the Self Learning Podcast.